Whoops, I messed that one up. Storms are a brewing. The mercury is on the rise. Is it getting hot in here? Or is it just the Mythwits? The show dedicated to all things geek pop culture, drenched in absurdity, and coated with sarcasm. Every week we bring you news and interviews from the Geekoverse. We do our damnedest to be funny, but there are no guarantees. Joining me this week is my co-host, Mike Kafis.
Is it cold in here, or am I just a climate denier?
No.
My other co-host, Jack Ballard.
Hello.
And our guest tonight, Gina Mazuka.
Hello.
Did I say that right?
Yeah, you did.
Oh, excellent. I don't have to read. The Italian names are a little easier than some of the ones we get. So Gina is currently a Ph.D. student at the University of Maryland, where she is studying atmospheric science and atmospheric chemistry. She holds an MS in atmospheric and oceanic science and a BS in meteorology. She spent the majority of her undergraduate and early graduate participating in a NASA field campaign where she traveled all around the country making meteorological and chemical air quality measurements, and was able to fly an instrument on NASA's P-3B aircraft during this campaign. Her main focus of research is modeling and analyzing the influence that thunderstorms have on air quality and surface pollutants. During fall 2016, she interned at the White House with the Office of Science and Technology Policy in the Department of Environment and Energy. I bet that was fun. All right, so Gina, welcome to the show.
Thank you for having me.
But before what's that?
It was just fall 2016. That's it's not too long ago.
Yeah. No. But before we go any further, one thing. Gina's opinions do not reflect the University of Maryland or OSTP. Any opinions, any of them discussed on this show tonight are those of the participants, that's us, of this show, and do not reflect those organizations in any way. Gina is off the clock, y'all. So whatever she says is her opinion alone.
Bye, Felipe.
right. So anyway, okay. So we're going to talk about tonight, if you hadn't guessed, we're going to talk about the environment, but more specifically global climate change. And this is a testy subject with a lot of people. We're going to try and stay away from the politics. I want to warn anyone who's tuning in now, or if you're listening to this on the podcast, or as an encore episode on YouTube. If you don't believe that science, that global climate change is happening, and there's nothing that will make you believe that, or you believe that it's some kind of conspiracy or whatever, don't listen to this show. Just turn it off, because we're going to go down that road. We're already there. So if that's the case, it's like
Time out, Pete.
What?
Do not tell someone if they don't believe to not watch, because maybe we have somebody watching who is on the fence and we can convince them.
Oh, well, I said
that's a good point.
If nothing would convince you, turn it off. If you already know it's a sham and whatever, then turn it off. Watch one of our other shows. You can watch some other show of some science you agree with. But
I dare you to watch. I dare you to keep watching.
Anyway,
don't listen to.
But we're not going to go down the political road. I just want to make that statement because I didn't want to piss any of our fans off. If you don't like that, whatever, that's cool. Move on. Watch something else. We got a great one. We just did one with Frank Menser. It was a great show. So that's all I wanted to say about that before we get started. So Gina, I think we should start with talking about climate change and everything. I think there's some very basic things that people need to understand before we go any further. It may sound really super basic, but I think it's important. The first one was, how does heat work? I mean, like what makes something hot? Where does heat come from in the first place?
Well, in our atmosphere, you have. Do you want me to talk about the atmosphere, or just in general, or
just either way? I was thinking just in general, like you have outer
right,
space.
So let's start on like a stove. Start on stove. Let's talk to those cooks out there. So. You turn on a stove and you have thermal conduction, right? The surface is touching this hot plate. And then through conduction, you're heating the bottom of your pot. And then through the conduction, you go to convection. And convection starts to heat the water. And in the atmosphere, works the same way. We have incoming solar radiation coming from the sun. and it comes through our atmosphere, and already 30% of that is reflected back to space because of the Earth's reflectivity, the albedo. The stuff that makes it to the surface is absorbed by the surface. But when it re-emits, it's now in long wave. And so solar radiation is short wave, and the stuff that the Earth emits is long wave. And long wave radiation is sensible heat, the stuff that you could feel. That's why we feel heat. And that is emitted from the surface of the Earth. And some of that escapes back to space. And then a lot of that is re-emitted by greenhouse gases. And so re-emit it back down towards the Earth.
Right.
So that it's all radiative balance budget.
And under normal circumstances, our atmosphere, and it does change over time. There are times when it's, when our planet has got a lot of ice on it, and there are times when it's, complete, greenhouse or whatever. And a lot of that has to do with the composition of the gases in the atmosphere. But it could also be it could be, it could be affected by solar. But from my understanding, solar doesn't have quite the impact. Like, we're closer to the sun or whatever. That doesn't seem to have quite as much impact as the amount of gases it can trap, or maybe the heat of a planet actually cooling down in the earlier stages.
The effects from the solar radiation. The solar cycle has an 11-year cycle, and you have solar max and you have solar min. And during solar max, we are bombarded with high energy from the sun, with particles, with coronal mass ejections. That will increase the total solar irradiance a little bit at the top of the atmosphere, but not enough to ever account for any of the variability that we see.
Right. It's like a drop in the
bucket. For anthropogenic. Tiny. It's you could kind of throw it away on when you average it out.
Okay.
On longer scales.
What's that, Jack?
So I was going to say, so if that doesn't have any effect, then the amount of insulation, I guess, in the atmosphere is what's causing the heat to not escape back into space. Is that?
So the greenhouse gases do that. A really great example is Venus.
Yes.
So like the Earth has what's called an effective temperature, and this is a temperature that you would see if you had a thermometer shining down on the Earth, just based off of how the incoming solar radiation that it sees. So Venus is obviously closer to the sun than us, than Mars, and Venus has a temperature at its surface of like 700 Kelvin, completely inhabitable. And the Earth has, our surface temperature is about, I'm thinking in Kelvin, let's see, 288 is Earth, so that'd be like 60 degrees Fahrenheit. So that's our global mean surface temperature. And then Mars is, much colder. But the reason that we are 288 is because of greenhouse gases. Without that, our Earth would be 0 degrees Fahrenheit. And Venus would be 220 Kelvin.
Right.
But greenhouse gases are the reason why you see these huge temperature differences. And Venus is full of CO2. It had a runaway greenhouse effect. So.
Right. And a lot of, some of our fans may not know this, but a lot of them are smart. They watch our show. Venus is the hottest planet in the solar system. So if you think it was just the sun or how close you are to the sun, you would say, Mercury's the hottest planet. But no.
Exactly.
Not even close. Venus blows it away. You can melt lead, maybe even steel on the surface of Venus.
You can melt lead.
Yeah, there's rivers of lead on Venus, if I remember, yeah.
I'm bathing in a river of lead. Yeah. I think that's where Flint's water comes from, right? The rivers of lead. No, never mind. Go ahead. I'm sorry. It's a terrible joke.
Yeah, I mean, Venus's effective temperature is actually less than Earth's.
Oh, okay.
Wow.
So without greenhouse gases, it would be less than Earth.
Wow,
that's amazing. All right, and then one of the other things I wanted to just touch on just a little bit with heat. I mean, it's just vibration. So vibration is heat, right? It's energy. Energy is heat. So the more energy you put into a system, the more heat it creates. And if you trap that energy, you trap the heat. These are just molecules bouncing around. And as I understand it, the reason why greenhouse gases are greenhouse gases I think it has to do with their molecular structure and the way they vibrate and the way they can hold energy, and when the waves hit them, they actually react more to the energy waves than other particles do.
Yeah, so say you have some molecules of nitrogen, oxygen, ozone. Those molecules, well, ozone specific, we'll talk about that later, but O2, nitrogen, these molecules that are all gases absorb in different wavelengths, like they have peak absorptions. And we know that because, like if you look at a star or, some celestial body, you could tell the composition of that. And that's due to the absorption spectrum. So we know that gases absorb at different wavelengths, and gases like oxygen, that absorbs at very low wavelengths, and so does ozone in the stratosphere. So they absorb at 0.1, 0.2, 0.3 microns. So that's really short wave. That's solar radiation. That's UV. And then gases like CO2, methane, nitrous oxide, they absorb at long waves. So 3 to 20 microns is considered long wave.
Mm-hmm.
So, well, yeah. so those gases, they have absorption peaks in the long wave. And in the long wave, they rotate and they vibrate, and that could give them a dipole moment, and that could make them very effective greenhouse gases and re-emitters. When O2 gets zapped by UV, by a photon, it photodissociates, it breaks apart and forms a new molecule.
Ah, okay.
But CO2, methane, they undergo different states of excitation, but remain the same molecule.
Right. And I think that's important for people to understand. I think that's some of the stuff that people miss in these discussions, because they're just like, well, how could CO2 affect it? It's just like, well, if you're pouring a whole bunch of this shit into the atmosphere, more than it normally has, and and then you introduce a whole bunch of energy into it, and it can hang, at the frequency that it just loves to eat it, right? It's going to heat up. I mean, it's just, that's all there is to it.
We're in a bubble.
Yeah, we are.
Yeah.
We're an aquarium. I mean,
a little fishbowl.
Yeah. Matter of fact, we just got a tropical tank. We put a heater in it, and water. Here's one other thing. There's two things. So there's the energy that water can hold. So there's a lot of water vapor in the atmosphere as well, and water is
water vapors.
What's that?
The number one greenhouse gas.
Yeah. Okay. Right. Well, and there's one of the reasons for that, as far as I understand it, is that because I used to do HVAC engineering, so I did climate control inside of buildings. So I kind of understand how it relates to all this other stuff. It all clicks for me. Water is it's great for holding energy, great for holding heat. Yep. It takes a while to heat water up, and it holds on to it forever. And that's why when you live like England, why England is not freezing. England should be freezing, but it's not, because it has water that carries a lot of heat with it that goes up through what they call the Gulf Stream. So it holds on to that heat for a long time. The problem is that it holds on to that heat for a long time. Once you start getting heat into it, it doesn't just go away. It's kind of like when you turn a pot off the stove, and that water just stays hot for a long period of time. It's why radiators work so well.
A higher specific heat capacity than the air or the land.
Right.
So it does. It takes longer to heat up, but it also retains that heat for longer as well. So that's why water really moderates weather next to coastal regions, for example.
Yeah.
Right.
Because the land is much more influenced by the water, because the water will have residual effects from like the season.
Right. And that's where we run into the next one I want to talk about, was relative humidity, which is another core concept that screws people up, because I may have some friends up north who don't buy into the whole climate change agreement here, because it's snowing up there. God damn it, it's snowing.
Oh, yeah.
Stupid global warming. But when I try to explain to them that, global climate change would actually predict more snow, they're like, that's just stupid. That doesn't make any sense. It's getting warmer. Oh, I guess that's why it snows so much.
Yeah, it'd be rain, right?
Right, yeah.
But anyway,
Yeah.
it's because of relative humidity. Because as the air gets warmer, as the atmosphere gets warmer, the molecules get further apart, and they can hold more moisture. There's more room for water to take up space in the atmosphere. So then that, and like you were saying, Gina, you got the warm water, and it evaporates faster because it's warmer, and the atmosphere can take it because it's warmer. And so it pulls that water up, and it goes across land. It comes across the land, and it goes, oh, wait a minute, the land doesn't hold as much heat as the water does, so now it's colder. Well, then the air temperature drops, and then the air can't hold on to that moisture any longer, and it lets go of it, and it snows. So that's why you get more snow when you have a warmer winter. And what I'm saying by warmer winter is you have a winter that's, say 30 degrees, cold enough to snow, but warmer than 10 degrees. And 30 degrees can hold more water than 10 degrees can, so you get more snow.
Like a nor'easter.
Yeah.
Yeah.
It's exactly it. I mean, like the temperature is like 28 to 32 degrees Fahrenheit. That's where you're going to get a lot of snowfall because you have a lot of moisture and you have a lot of relative humidity, and so that makes it available for these storms to fuel off of that.
Right, and
well, I was surprised to learn that water vapor was a major component of this, and that kind of takes me by surprise because for so long we've been hearing about like fluorocarbons and the emissions from vehicles and all these other man-made components and coal being burned and the Industrial Revolution and stuff. So how much of this is man-made in the equation? I know that's like the $10 million question, but yeah.
So it's without a doubt, the warming that we've seen since the Industrial Revolution is in large from anthropogenic sources, from man-made things. There's nothing that we could account for naturally that could explain the rate of warming or the rate of CO2 increase. Water vapor is a very effective greenhouse gas just because of its composition. It has a natural dipole moment, whereas CO2 and methane, they need to get zapped to have that dipole moment. But water vapor is also a feedback. So as the temperature increases, water vapor increases and vice versa. Water vapor doesn't increase temperature necessarily. It is a feedback of temperature, whereas CO2, methane, N2O, the other greenhouse gases, as they increase, they increase, the temperature increases with them. So water vapor is a little different because, we're not emitting water vapor. No one's worried about, anthropogenic water vapor emission.
Unless you vape.
It's just part. Oh, vaping. That's true.
That's true. Oh, yeah. So hipsters are destroying the earth. All right, go ahead.
Curse those hipsters.
All right,
yeah, I mean, so yeah, I mean, CO2 is over 400 parts per million, where it was 270 parts per million pre-industrial, and that we count that towards people.
Well,
okay.
I saw, if I just one more follow-up question here, because I also know some climate deniers, and one of them posted this thing the other day about how a volcano went off and created all of this, all of these, bad things in the atmosphere, so much more than what man makes in the last 400 years. So is that like volcanoes spewing hot, basically water vapor as well from the how is that measured into the equation as well when we talk about what
a lot of people actually I mean people study volcanoes very extensively and their effects on climate, and sometimes you just want to even subtract volcanoes out if you're looking at anthropogenic, but volcanoes aren't a constant source. I mean, they're one big event. They spew their stuff. Most of it goes in the stratosphere, stays there for a while. You have some effects of actually cooling because, you have aerosols in the stratosphere, which act as little reflectors. And I'll remember that shortwave incoming solar radiation is getting reflected back even more than the before.
Right, that's what I would say. Like when you have a winter effect or a cooling effect when you have volcanoes going off.
Yeah. But they also spew a lot of these gases, and so yeah, I mean, people study that extensively, but like I said, it's not a constant emission source. It's not something that, like we don't have any control over it.
Right.
What we do have control over are humans and
Right.
the stuff that they're spewing out constantly every day.
Right.
All right.
Right.
So
I agree.
To some level.
I have a question for you, and this again is it's not like we're trying to aim and take pot shots at climate deniers, but
Yeah, we are.
I think it's
something was in my throat.
I think it's a way to point at the evidence, and so I guess part of it is what I'm asking, related to the evolution of climate. Is a lot of people will say, "Oh, well, the Earth naturally go," and I honestly was sort of on this camp for a little while. I thought, well, this makes sense to me. A lot of through history, we've had, we go through why am I losing it right now?
Ice
Cycles.
Interglacial periods, glacial periods. Yep.
We're just waxing and waning from this thing. So knowing the studies that you've done, and between that and geology and the weather patterns we've seen throughout the millennia, what is there? What is the history of climate?
From
the earliest time, or I mean, the climate
Mike
has undergone a lot.
A little vague there, huh?
What is the history
so,
of the Earth, please, Gina? Could you just
How did it all start, this history of weather?
The Earth was a very different place, 3.5 billion years ago. And, it was totally different chemical composition. And there's a lot of outgassing, and there was no oxygen really at all. And it was mostly methane. It was in a reducing atmosphere, mostly methane. Mostly the only living organisms were prokaryotes, one-celled, were you going to say something?
I was just going to say, hanging around in Pete's house, there's still a lot of methane, but still, please go ahead.
There's a lot of outgassing.
Yeah.
So the state of the carbon favored methane at that point, and then there was the big oxygenation event, where these little single-celled organisms, one nucleus organisms, they were dying off because oxygen started to form because of photosynthesis. So oxygen went from 1 part per million to what it is currently, and so it's kind of
like antioxidants.
Yeah, it was there was not much oxygen at all in the early Earth. And then, then we had the oxygen event, and we see oxygen levels similar to what we see now, and that gave rise to all of the organisms that we see. You got moss growing, and then you got ferns, and then people, and and so on. So, and then it led to forests and starting to take. So CO2 was very high when oxygen boomed, and because now the favored state of carbon was CO2. And not methane anymore. So CO2, lots of CO2, but then we had forests, the rise of forests, and they would take in that CO2. And so over time, as forests grew, CO2 started to kind of reach an equilibrium. And CO2 was very high 500 million years ago, way higher than it is today. I don't know the actual number off the top of my head, but a lot higher than we see today.
But that was when the Earth was like a giant swamp at that point, right? I mean, it was like a big, hot, wet planet, right?
Yeah, I mean, during oxygen, I'm not going to say that word anymore. It's just oxygen. When oxygen came, that's when we got the ozone layer to form. That's when amphibious creatures were able to leave the water and be able to be on land because they're protected from the UV radiation when the ozone layer developed.
Oh, cool.
Okay, yeah, that makes sense.
And,
okay.
Yeah, so I mean, CO2, when the Earth went through a lot of, so we went from that, and then we have, the orbital cycles. We have the Milankovitch cycles, where different orbital configurations will make the planet colder and warmer, and it induce the ice ages, and so CO2 changes. But the thing is, we understand natural variability quite well, and the part we don't understand is how it's warming right now and how CO2 is at the concentrations that it's at, given the understanding of the natural variability and knowing where we are in that natural variability. There's an unaccounted source, and it has to be this infection of humans.
Right.
Yes. Indeed.
Right.
I mean, when you understand how greenhouse gas effect works, when you understand physics, and when you understand the way that planets align and our effects from the sun, and then you have this mystery source, and it just so happens to coincide with the time that the Industrial Revolution occurred.
Yeah.
Yeah, because
it's a given. We know what this is.
It's not like the scientists can go out and like, let's pull all the atmosphere in and test it all. I mean, you get you could test it, make assumptions, test areas, take core samples and see, hey, this is what the atmosphere was like then, this is what it's like now. We know how many we know how many volcanoes have gone off, because guess what? We monitor that shit. And we can monitor what's coming out of those volcanoes even more now than we used to. We have satellite imagery where we can actually see this stuff with spectrometry.
Exactly.
So we can see this stuff. I mean, they can look at a volcano with a satellite and go, this is what's coming out of it, and they know. And so it's not like a big question like geez, we're just gonna throw a coin and guess. There's some guesswork, but only because it's a big fucking planet. But for the most part, they don't really need to guess on a lot of this.
Just from a historical point of view too, people who lived by the steel mills in Baltimore in the 60s would have to wipe their car windshields off of soot and black powder from the residues coming off from Bethlehem Steel. So, I mean, even in just 50, 60, 70 years ago, before all these air regulations and Clean Air Acts were passed, the air quality was absolutely abysmal. And it was what was causing it. What in Baltimore, besides our neighborhoods, are burning to emit this kind of black carbon on windshields? I mean, could you imagine waking up and cleaning your windshields off every morning of soot like that?
Can you imagine what you were breathing in all night long?
Yeah.
I mean, air quality is a success story in this country, and the reason it's a success story is because of the regulations that were implemented. Flue gas desulfurization, catalytic converters in cars to get rid of NO, more complete combustion to get less CO. It's unbelievable. And you see in everything, you see in acid rain and SO2 and ozone and NO2, and all of these just dramatically decreasing in the last 20 years or so. And it's crazy that people don't think that this should be regulated when it's a beautiful success story. It's still not great, but like how you could not think these things need to be regulated is astonishing when it's directly linked to human health.
Yeah. I think there's more people die from particulates in the air than just about anything else. I mean, I think it's one of the leading causes. Asthma deaths and complications. I don't know how high up it is on the chain, but it's way up there.
Oh, it's up there. And particulates are the worst. They really are, because not only are they terrible for air quality, but they are the biggest uncertainty in modeling climate. The aerosols. Aerosols are the worst, because their uncertainty is the thing that scientists disagree on. That's why the models don't converge for the most part, is aerosols. When you project it out forward, aerosols are a big issue.
Some of the things I see, I think that the people have problems with is that, the scientists don't get everything 100% right all the time. So scientists seem to be held to this if you don't get it all right, you're all wrong. And like, and chaos there.
Try being a meteorologist.
Right, exactly. People
Right.
are always bitching about, oh, why can't the weatherman get this right? It's just like, do you have any idea how complex?
Why can't I get exactly the rate of snow that I thought was going to happen in this pinpoint location at this exact time? How could you not predict the weather better? How could you not predict the future better?
Right, exactly.
I'd like to see them predict the future.
While you're in your office with your computers and your Doppler radar, I'm out there sacrificing getting the real weather right.
Mike,
I once heard somebody told me that as far as predicting the weather goes, the East Coast of the United States, from about Virginia to Maine, is one of the most difficult areas in the world to predict the weather. Is that the case? Have you ever heard that before?
I've never tried to predict the weather anywhere else in this country, to be honest. So I have no idea, and I'm not even very good at that. So that's why
Phoenix, Arizona is pretty easy.
I'm not a forecaster.
85 and sunny today.
I believe that, though. I mean, you have a lot of complex terrain, and you have a lot of water influences. You have the Atlantic, and then you also have lakes, and that throws everything off. You have the mountains, and that is actually very difficult to predict.
Right, because Florida's like a terrarium. It's always the same temperature. It rains at 3 o'clock in the afternoon every day.
Right,
it's the weirdest place.
It's going to rain today for 3 minutes every day at 3 o'clock. I mean, pretty much. You'd be closer than you would here with anything. Although I think they're getting better at it.
Groundhog Day.
Yeah.
Yeah.
Exactly.
It is.
Groundhog.
Without Bill Murray.
That's crazy. People put more trust in that groundhog than in meteorologists to tell them the short-term forecast.
It's true. Well, that's a metaphor for science and the public at large anyway. They'll believe a big furry hamster before they believe numbers and charts. That's people in general.
Dude, that is perfect. That is perfect. America has become Groundhog Day.
Don't drive angry.
Right. Jesus. Oh, God, help us all. All right. Hey, did you know, just real quick, I was reading an article about that because the movie was around. Do you know he was in that loop according to, oh, crap, I can't remember who made the movie. Shit, I was reading about this. But he said, I can't remember who, whatever. It was like 15 years he was in that loop.
What?
Really?
Yeah. Because he said originally he thought it was only like a year, a couple of years, but then fans started going through it, and they were like, well, how long would it take you to get good at this and good at that and good at something else? And all the things
because he learned to play the piano and speak French. Yeah, I didn't even think of that.
Right. Yeah, so the guy who made the movie, and for the life of me, I can't think of his fucking name at the moment, but he went on record saying, I think 15 years sounds about right. So
wow.
Can you imagine being stuck in Groundhog Day for 15 years? Jesus. Needlehead Ned.
I'd love to not age at all like he didn't. That'd be good.
Yeah.
Yes.
Not on the same day in that shit town. I don't know.
I know.
Right. Anyway, so let's talk a little bit about the effects of what we got a good feel with what climate change is and how it comes about and how we have a pretty good idea that we know what we're talking about here. So what have we seen so far? What has happened to date? Like what things have happened that we can put our finger on and go, yep, that was climate change. That was climate change.
Okay, we'll start with CO2 levels. CO2 concentrations are the highest that we've seen in 650,000 years.
Yes.
Wow.
Okay. Wow, that's not good.
And then for temperature, 9 out of the 10 hottest temperatures years on record in the instrumental record. So that's 1880s to 2016. 9 out of the 10 years have been the warmest on that record.
That's not good.
The Arctic sea ice extent was the lowest in 2012 than on its record. The melting of Antarctica and Greenland is very terrifying. I don't know if people are aware that these are land ice
Right.
sheets, and so if you're just thinking, oh, well, it's just an ice cube. It's just going to melt and it won't displace anything. These are things that aren't in the water. So when they melt, they will displace a lot of water. If Greenland melts, it's about 60 meters sea level rise. And if Antarctica were to melt, it would be 60 meters sea level rise. I don't think that we need that. So we saw a doubling of the loss of Greenland in its instrumental record. What else? Extreme events. We see a lot of extreme events. That's the thing, it's really hard to say when, something happens, you can't necessarily say, oh, that's because of climate change. It's the frequency of extreme events that is attributable to climate change.
Right.
How much has it been?
I'm sorry, what?
How much has it been increasing that frequency?
Well, in our country alone, we're seeing very extreme drought that, once again, isn't part of any cycle that we are aware of at the moment. So extreme events could be drought, heat waves, doesn't necessarily mean big storms. It could be, things that really affect national security and our ability to thrive as a country. If we're not able to live off of our own, farming and water reserves, that's a really big issue. And we're seeing this happening. And I can't forget about ocean acidification, which I think is, that's something that, even if you want to talk about not understanding the projection forward of climate change, we could disagree all you want with the models projected forward, but the data to current date, and things are changing. That is without a doubt. And ocean acidification is one of those things that is terrifying. The ocean is getting more acidic, and it's getting more acidic because more CO2 is being absorbed into it.
Right.
And the ocean acidifying is terrible. It's really scary for little critters in the ocean. Yeah. It's really scary for us to know that this CO2 is being dumped into the ocean and destroying our biology in the ocean. And we rely a lot on that biology pump to take the CO2 from the atmosphere and keep it, regulated. So the ocean is just being kind of overwhelmed in that upper layer of the ocean with CO2 at this moment.
And it's terrifying because, it's known that once the ocean collapses, if the biosphere of the ocean collapses, we're next. We're next. Yeah. And this is not like a maybe we're next, or well, I live in Colorado, I'm nowhere near the ocean. It's you're done. We're done. We're gonna, not every person's gonna die. It's not gonna be the end of civilization. No, it'll be the end of civilization as we know it. I figure there will be.
Fine.
No, it's not going to be fine. It's going to be anything but fine. It's not going to be good.
Pete, I don't need your goddamn scared straight climate tactics. Okay? I don't need that. All right, listen, I will do my part. I will stop peeing in the ocean. All right, I'll give you that. Okay. I will do my part.
But it's terrifying, and we see it. I mean, it's very clear. The coral reefs are dying in unbelievably fast. They're being bleached by the pH levels going up.
Exactly.
What is it? The barrier reef is taking a massive hit.
What's getting?
What's that?
What's getting bleached?
Stop it! Not your barrier reef.
No. That's a no danger.
Right, the only thing it's gonna. Oh, never mind. Anyway, so
fudge. Are we still gonna be able to get fudge?
Yes, I think. Okay. I white chocolate fudge. So anyway, I was up in Alaska for work a couple of years ago, and I was talking to one of the guys that was working up there. He lives up in Alaska, one of the mechanics there, and was on a military. I was up in Anchorage at their military base, and we're standing outside. We were talking. He was taking a little bit of a break from working, and I asked him. I said, hey, have you noticed? Like, I mean, have you personally have noticed any, reduction of like, winters and stuff up here? Is how's because I know that global climate change affects the northern regions a little more severely than the southern regions. And he's like, oh yeah, he points over. He goes, you see that glacier? And I was like, I'm looking around. I'm like, no, I don't. He's like, you used to be able to. I was like, oh. And this is a guy who he lives there. He's lived there all his life. And he says, yeah. He's like, you used to be able to see that from here, but he's like, you have to drive down the road to go see it, see what's left of it. And he said that it doesn't snow like there and like it used to. And that's not just like one storm or in a couple of years. He said it's pretty bad. He said it's been getting milder and milder and milder every year. And having one mild winter doesn't say shit about anything. Okay, you can have a super mild winter, you can have a super heavy winter, and that doesn't mean anything at all. It's like you said, it's the 9 out of 10 years hottest on record. That's where you start going, oh shit, we got a problem. Because like you could say, I mean, we in Maryland, we've had nothing. We've had 2 flurries, Yeah. But I wouldn't go out on a limb and say, oh look, that's global warming. I would say, look at all the winters we've been having in a row that have been mild. That's global warming. The other was just a bad winter, or a good winter, or I don't know, depending on how you look at it. But yeah, that's some of the stuff that I've been seeing, and I've also been seeing reports on things like one of the coastal town in Alaska is starting to go underwater. There's this one native town that they keep retreating back because as the water slowly, because we've had some water rise, right, over the last decade or two, haven't we? Mm-hmm. I think I saw something on Vice, one of the reports on Vice about one of these water nations, one of those like island nations is actually figuring out what they're going to do because their island is going under.
Water world.
Yeah, I mean, globally, average sea level has increased about 7 inches in the last 100 years.
Ooh, wow. That's a lot.
Especially if you're living in New Orleans.
Oh yeah, well New Orleans is below water. I mean, it's not. I don't know why they. I honestly don't. I have no clue why they rebuilt. Why would anybody rebuild there? I mean, I thought that would have been a sign. Like, all right, that's it. Pack it up. Let's move New Orleans. Let's move it. They moved cities. Yeah. Ramses moved a city back in the fucking Egyptian days. We could do it. Well, got technology. All right, so
not in my yard.
Right,
so where would we move Baltimore to? Like Carroll County? Is that?
No, we just let it sink. No. Move it up here to Blair.
Go down with the ship.
Move it north into Blair with everybody else, Jack.
Yeah.
All right, Peter. We're running short on time. So what else do we want to talk about before we?
Okay. All right. Fantastic. Let's see. Let's do this. Let's So, I mean, I guess it's safe to say things that we're going to see coming. Okay, we have more snow during the winter. We're going to see that. More rain during the summer, and more drought during the summer, depending on where you are and how the climate affects you.
Depending on where you are.
Yep, depending where you are. Too much rain. Because like
flooding, slides.
Mudslides, right. Because California, they were drought, and now they're fucking underwater again. Because it's like feast or famine with water with them.
They're not flooding; they're on fire.
Right. If they're not flooding, they're on fire. Right. All right. I want to share something with you guys before we have to wrap this up. So let me see. This sharing thing always gets a little tricky. So I'm gonna do a share screen. All right. Okay. You guys see that?
I do.
All right.
So is that where the property is going to be?
What's that?
Is that where the beachfront property is going to be?
Yeah, basically. So this is a map that I found online. I'll tell you I'll give you the link after we're done with this because I don't want to close this down because I'm sharing it and it'll show. Anyway, so this is our hometown. This is Baltimore, hon. So the image on this image here that's on my left. That is a 4 degrees Celsius warming. That's if we do nothing. if we have no curbing within a certain time period, this is how much water we're going to see. So I don't know. Jack, where do you live? Are you underwater on this one?
I am not on this map. I am
Okay.
up on the upper left, but I'm not far. I'm within, I'd have some lakefront property. That's for some
All right.
bayfront. Yeah.
Yeah. So all of the inner harbor's gone. Out pretty
It's just
far. Huh?
it'll be moved. It'll be moved.
Yeah, sure. We'll just pick it up and move it. And then the image on the right, that's with that's if we do incredibly aggressive carbon cutting right now. Start right today.
Wow.
This is where it's going to be. And I think what this is saying we have some points of no return. This is one of them. So if we do nothing at all, this is where we're going to wind up on the left here, and on the right if we start cutting aggressively now. So we're in pretty bad shape as it is, as far as they can tell.
Well, where 83 is, where that big highway was coming in and ends in the roundabout, that was a lake bed. That was a riverbed. That was the Jones Falls River. So that's all that there is below sea level as it is.
Right.
So yeah.
So then
that's the best part of Baltimore. That's sad.
So then here's New York.
Man.
Everybody knows New York, right?
I know. I've been there.
Yeah. So this is this tip down here that's Manhattan. So a good chunk of southern Manhattan gone. I think a good chunk of New Jersey. Not that anybody really is going to worry so much. No, I'm kidding. But like that's New York. So for our West Coast peeps, this is San Diego.
Is the Jersey Shore gone? The Jersey Shore will be gone, right?
Yes, Jersey Shore will be gone. There is a silver lining in all of this. All right, so anyway, so here's San Diego. Now, I'm not really familiar with San Diego. I've never been there before, but this looks pretty bad. There's a piece of land here that becomes an island, so that doesn't seem good. And there's an island that becomes sea bottom. All right, so here's an interesting one. This is Miami.
Wow.
So nothing we do, Miami. I'm sorry, but
isn't that a little spot? There's a little spot there, or no? That's not.
Well, there's a tiny little. I think that's a building, though. If you live in a penthouse, yeah.
Wow.
But here's the scary as this is.
Oh no.
Here's Florida. Bye-bye.
Yeah.
Oh,
bye-bye.
Well, it's just the keys move up.
No, this is.
What's the timetable on this?
I don't know. It's basically if we don't cut any, this is where we're going. I don't know what that means.
What's 2 degrees? So yeah, I don't know.
So 4 degrees or 2 degrees C. And for all you English speaking people, that's 3.6 Fahrenheit or 7.2 Fahrenheit. But that's what I have for that. That is a map, and you can go look at that yourself if you go to, hold on. If you go to, because they that's part of the agreement to share these images. Blah 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 blah. Shit, where is it? Where'd it go? I'll put it in the show notes. I thought I had it in. Oh no, I got it. Here we go. It's sealevel.climatecentral.org, and you can play around with that. You can go. You can look up any city you want, any place you want on the earth.
Wow,
it's pretty neat. Pretty neat. Pretty scary. So yeah, that's what I got. I guess the only thing before we wrap this up with you, Gina, what can we do? I mean, what is it? What can be done?
There are a lot of things to be done, but the biggest worry is, okay, we've done our damage in our country for the most part. We are a developed country. We spent 1750 to now developing our country and making it what it is. There are countries that are less fortunate than us. There are countries in Africa and all over the world who are not developed yet and are trying to become developed. And what they need to do is become developed in a way, and don't make the same mistakes we made, become developed in a very sustainable way, and not be releasing the same amounts of greenhouse gases that we released. And that's why the US was a part of the Paris Agreement. So so we can make sure that we have a hand in making sure other countries don't do the same disservice to our planet, making sure that other countries stay on task, including ourselves.
Right.
I mean, and that goes down to each, 300 million cars being on the roads in our country. Like, just every little small thing at some level will help, but the big things are the developing countries and, mitigation, transportation, and energy. And I am hopeful for the future. I am worried about the future, especially in our country.
Yes.
But
Yeah.
We have to be optimistic.
Some of the things that we do.
Yeah.
Some of the things we do that make ourselves feel better, we really feel like it is, but it doesn't, is, we recycle, and we take all of our technology that we are finished with, and we break it down efficiently and all this stuff. But a lot of times we don't. I was listening to and reading an article that was talking about the fact that there's 2 third world countries who are making money by burning it, by incinerating like monitors and cell phones and stuff, and all that crap is going into the atmosphere. So like you were saying, these countries that's the only way they're making money, and we are, we're not supposed to. And it's one of these kind of a shady, but it's semi-legal, I think they call it. It's like, well,
we're not burning it.
Yeah.
Well, it's like when we have things manufactured in China, for example, and then China gets in trouble for their emissions, but we're the ones who are consuming the product. And you're shipping it over, you're shipping it back, and that's emitting. And then we're not getting in trouble because we're not the ones producing it, but we're the ones consuming it. So it's really, and really the energy sector, we need to get away from non-renewables. Coal. Coal is. That's hard for me to say because I'm from Coal County, Pennsylvania, but it is what it is. It's it's a big problem, and
it's interesting because we have people here
enlarged from it.
We have people here in Maryland who drive electric cars, and they feel like they're doing something good, and I guess it's kind of good, but the one thing that concerns me about that is where that electricity comes from. It's like, well, your car's not emitting anything, but the electricity that your car's running off of is coming from, if you live in Maryland, chances are it's coming from a coal-powered power plant. They're burning coal to get that electricity. Electricity didn't just fly out of the air, So that is a concern. That's not the total answer. And I don't want to go down the rabbit hole in this because we're running out of time, but just real quick, what are your thoughts on nuclear energy as a possibility? Because I'm a fan. I'm a super, super big fan of some of these new designed power plants, nuclear power plants. I really think that could be a big saving grace.
Did you say nuclear?
Nuclear. Hey,
nuclear?
Son.
Okay.
That nuclear. No, nuclear. I can't say it. Nuclear. I don't know. Shit. I always say it wrong. And then when I say it right, I think I said it wrong.
Say oxygenation event.
Oxygenation event.
Oxygenation event. So I can do that one. I can't do nuclear, but
nuclear. Get that nuclear power.
All right. So
that's like Schuylkill County.
Right. So one last thing. It's something that you brought up in your notes, and I want to give you a chance to talk about it just real quick.
Sure.
Why is geoengineering is crazy until further research? What is geoengineering? What is that?
So I remember in the beginning we were talking about how volcanoes release sulfates, aerosols into the atmosphere, into the stratosphere, and it acts like a mirror to incoming solar radiation. It reflects it right back. Right. And there's so much talk of just geoengineering the planet, meaning we release these into the stratosphere, knowing concentrations, and let it kind of spread out. And over some period of time, it would reflect back enough incoming solar radiation to help mitigate the amount of temperature rise at the surface that we see. And it's funny because it sounds smart, right? And it sounds like something that would be possible, but there are just so many so many side effects that are unstudied, and it hasn't even been really fully looked at. Like what would we do about ocean acidification if we just let the CO2 keep building up down here, and then just get rid of the incoming solar radiation so we cool it a little? But the Earth is still going to be in a very scary chemical soup that we're going to have to deal with regardless of the temperature.
I got an idea.
Wait a minute. No.
Hold on a second.
What?
Wait a minute, Mike. She said scary chemical soup. I think of your bedroom when I hear that. When I hear that phrase. Go ahead.
My cauldron.
Right.
All right. So my idea is, you guys saw Rogue One, right?
Yeah.
Right. Remember,
I kind of fell asleep.
What?
Here. Okay, so at the end of the movie, near the end, then you wouldn't have seen, there was this big, the whole planet was in this force field, and then there was this one part that was open. So why don't we do that? Why don't we just bust a hole in the atmosphere, and we can just vent shit when we want, like a smokestack for the Earth,
like a bathroom spark fan for the atmosphere.
Right.
Hey,
Jack, you're kind of there.
I'm sure there's some places in Africa where we could just drop a bunch of nuclear bombs, right? And we give us a nuclear winter that would cool down the planet. Come on. It's simple.
No.
Get some satellites with laser beams on them.
I'm talking some sound science fiction right here. All right? Don't go with that bullshit.
That bullshit.
It's very sound.
It's very sound. Yes, Mike. You win the award. All right, Gina. Thank you for joining us, but stick around because Mike, I believe you have a game. Gina, can you stick around for a few minutes?
Yes.
Sure.
Sweet. All right. Oh, wait a minute, real quick. You can find Gina at www.atmos.umd.edu/tilde. GMAZZUCA. It'll be in the show notes, of course. You can find her on Facebook at /Gina.mazz.3. Wow, there's two other ones. And Twitter, Gina's Life, GINASLIFE. And another link here, weather.umd.edu. And Gina, thank you for coming on the show.
That's a promotional link.
Oh, is
that
it? Okay,
weather.umd.edu. Great place for weather in the Maryland area.
Go check it out.
I will check it out.
The edu. The edu.
All right, so Mike, I'm going to turn the show over to you.
And the sound's not working.
It's working. You're good.
It's working. I can hear it.
Yes.
How am I not hearing? Okay, whatever. So we are going to be playing Match Wits with the Mythwits, and we will. I'm not. It's just screwing me up because I'm not hearing it. So okay. Anyway,
it's done. You're good.
I know it's done. I heard it not being done. Okay. So Gina, what's gonna happen? You remember the old Match Wits game or match game? Ever hear that? No. You'll
might predate me.
Does date
make you guys feel old?
Yeah.
Yes.
Gina's about a third of our ages.
You remember the 70s? times. All right, Gina. I'm gonna ask you a question, and that question is going to demand you to fill in a blank. You can fill in that word with any word but blank, okay? But before you reveal your word, we're going to have Pete and take a stab at your blank. Now, I know Jack is family, but it's okay. That he is going to predict what your blank is. So we are first going to look at their answers, and then we're going to have you reveal your blank, and then we're going to see who gets points. What do you think?
All right.
Hey, Mike, why don't you play along too? That'll give us 3 players.
I can play along.
Okay.
Believe you.
All right, so we'll go Jack, Mike, Pete, because that's how I have them written down. Does that work?
Okay. I think so. Let me bring up that here. So, guys, for whatever reason, I had two questions that were Hulk related. So this is a theme. This match is the Incredible Hulk related. I don't know why. There's not a movie coming out. It's not even related to the movies per se. But there will hopefully be some hilarity. Okay, you ready?
Yeah, ready.
All right, who's first, Pete?
Me.
Jack. Well, you're just going to read the question.
Let's hear it.
Okay.
Yeah, Jack,
All
me,
right,
and
guys. All right. So, when the Hulk found out Loki was going to be his cellmate, the first thing he did was trade Loki for a blank. When the Hulk found out Loki was his cellmate, the first thing he did was trade Loki for a blank. Gina, Lockett, if you have find a pen and paper down there, you can try and write it down, or if not, you can just and when the time is right, you will just give me your answer. I believe you. But oh, there it is. I hear it now. I didn't have a button pushed the way I should have had it. Okay.
All right, that's enough of that music. Kill that music. Killing me.
Good God, I know.
Stop playing it.
All right, Jack. When the Hulk found out Loki was his cellmate, the first thing he did was trade Loki for a blank.
I'm gonna guess that Gina has no idea who the Hulk or Loki is.
So Loki is actually my cat's name.
Oh shoot! So I am dead wrong.
But only because he's the Norse god of mischief.
He is,
and he keeps me up all night.
That's a good name for the cat. Shit. So right off the bat, I'm wrong. I'm gonna say her blank is blanket.
Okay.
No.
So when the Hulk found Loki was his cellmate, the first thing he did was trade Loki for a blanket. Okay. Peter.
Yes. I had a hard time. Go ahead. I cut you off.
Yeah, you had a hard time.
I had a hard time with this one. I don't know why. I was drawing a blank, as it were. I just went with hammer. Trade him for a hammer.
Okay. All right.
It's not a good
That's cogent. It's cogent. So, all right, Gina.
No, Mike.
I said mine was a pack of cigarettes.
Okay. They are in a cell. Yeah.
Answer. Yes. So, Gina, this is why we usually write it down so that we can have an honor system thing. But that being said, the Hulk found out Loki was his cellmate. The first thing he did was trade Loki for a blank.
Soap.
Oh, nice.
All right. Very good.
Ooh, good. Good.
That was a good round. Nobody matched, but I think that was a good start. That was a very good start.
Very good.
And now that I can hear the music, I'll be able to cue it better and volume it better and everything else.
It's a little loud. Oh.
Yeah.
Here we go. Round number 2. Bruce. This is my favorite one. Bruce Banner ate some bad sushi. It would. Bruce Banner ate some bad sushi.
How bad was it?
It was so bad, he hawked out and then blanked.
Ooh.
Bruce Banner ate some bad sushi. It was so bad, he hawked out and then blanked. It was so bad, he hawked out and then blanked.
I'm in.
Oh, I on this one. I have a feeling, and there's loose. This is part of the pun. There's going to be some loose matching.
Loose.
Is everybody
especially
ready?
After mine?
Okay. Jack.
Yes.
Jackie, buddy. Bruce Banner ate some bad sushi. It was so bad, he hawked out and then blanked.
Oh, shoot. How can I get this in? He pooped. That's what I do after some bad sushi.
You hulk out and poop.
Yeah, it's all those carbs. It really is.
Okay. All right. Okay. All right. Peter.
Yeah. So I know the Hulk is green. I know that. Okay, but it's a bit of an anomaly here. It was bad sushi. I said he shot out a blue waffle.
Not gonna match. What do you know? Because I said, Bruce, and I don't know, Gina, I'll let you be the judge of this maybe, but Bruce Banner ate some bad sushi. It was so bad he hawked out and then painted the town brown.
Oh,
wow.
That's pooped.
Yes. So
we all went in the same direction.
Definitely in the same direction. And that was why I chose this, because you could have gone in another direction. Gina, which direction did you go in? Knowing that
I don't know, it didn't even make sense. Like, it really doesn't even make sense. He ran away.
I'm gonna ask you clarification.
He didn't want to be around anybody.
So
He didn't get runs. He didn't get runned away.
right, he ran. But you know what,
Runs
Mike?
away.
That's a match with you and Jack.
All right, I say yeah, Jack and I, we're a match. We get 500,000 apiece.
Yeah.
Sweet.
If anyone matches you, they get 1,000,000 points, and if we match each other, we get 500 apiece, 500,000 apiece. So, move on, my friends, to round 3, and that is that Lou Ferrigno was asked if he would ever play a live version of the Hulk again, to which he replied, blank. Lou Ferrigno if he would ever play a live version of the Hulk again, to which he replied, blank. You know who Lou Ferrigno is, Gina? He's
No.
a guy back in the 70s. Yeah. This will be a good one for you. So I have a feeling Jack and I might match this. I don't know. All right, guys, come on. What do you think?
All right.
Jack, when Lou Ferrigno was asked if he would ever play a live version of the Hulk again, he replied,
I'm deaf, dumbass. Write it down.
all right, okay. Pete, you might have to break the tie on this. Go ahead, Peter. What did you say when asked if Lou Ferrigno would he
Jack and
play
I
a live
both
version
went
of the Hulk?
we went both went for the same low hanging fruit. I didn't write mine down because I don't know how to spell it. What he said was "After Wolf man."
That's horrible. You guys.
You guys are such assholes.
Oh, that's terrible.
I'm terrible. Bad.
Now, Gina, this is what I said.
I have no idea who this is.
This show was
it even
off the
better.
air like 30 years before she was born, by the way. That's like,
Right.
When Lou Ferrigno was asked if he would ever play a live version of the Hulk again, he replied, "What?"
the guy who played the Hulk in the original TV show in like the 70s was a huge bodybuilder guy that was deaf.
Yeah.
So that's
Right. So we all are absolutely picking on that as the low hanging fruit because we're all jerks.
because we're terrible human beings.
We are. But you know what, Mike? I'm gonna call all three of us matching each other.
I'll get a match.
But
yeah.
but
yeah.
what did
What Gina said?
yeah.
Gina said, "Get me off this podcast with these creepy old men."
Gina says nothing. No, Gina says,
Woo!
"Woo!"
Woo. Was it woo? Okay. All right. So I'm gonna say me, Jack, and Mike all matched on that one because yeah.
And hold on a second. I just because I got to do this real quick. Gina, this is what Lou Ferrigno looked like right there. Peter,
The black screen?
Yeah.
Oh, there he is. That's
There
Lou
he is.
Ferrigno.
That was the Incredible Hulk when we were kids. That was our. That was our. What is that?
I
That was
just-
our CGI right there. That was CGI for us.
That was
I took like a Ric Flair woo on it.
Yeah. Woo!
Woo
Fantastic.
was a good choice.
That was a good choice.
Okay. All right. Well, it's good stuff. Maybe you can relate to this one.
So, Mike, is that our last one, or
This is the last one coming up.
this
right
is last? Okay.
All right.
All right, because you're killing me. No.
Okay, here we go. Batman drives the Batmobile, and Spider-Man has his dune buggy. Did you know that? Did you know that, Gina? That Batman had a dune buggy? No, you didn't know that, did you? Okay,
Back in
but if the Hulk had a vehicle, it would be a blank. Batman drives the Batmobile. Spider-Man has his dune buggy. But if the Hulk had a vehicle, it would be a blank. And I went sensible on this. I went with something that made a little sense. Just put that out there. Not trying to say if anyone wants to match me. Just saying that Batman drives a Batmobile. Spider-Man has his dune buggy. And if the Hulk had a vehicle, it would be a blank. So, Jack?
Man, this was really hard.
Yeah. What's up, man?
I'm thinking taco truck.
Taco truck.
Okay.
I
think.
I mean
A
taco truck. I'm hungry, so I think that may have influenced my decision. And I'm a big fan of taco trucks. And Hulk driving a taco truck, holy shit, that's about the coolest thing in the world right now. So taco truck.
Actual Hulk or Lou Ferrigno?
Either one. You wouldn't want to piss him off though. You wouldn't like him when he's angry. But yeah. Either way.
All right. Peter?
El Pastor, please.
What is the Hulk driving these days?
Again, this was a tough one. Very hard to put a double entendre on this one. I went kind of sensible for once, and I said tank. Drives his tank. It's a big old Hulk and tank.
You went ultra sensible.
I did. It happened.
Good for you, buddy.
It does happen.
That was good. All right. Well, I said that he would drive a mean green machine.
Oh, very good.
Oh,
Yes.
very good.
Yeah, another thing that Gina would have no idea what the hell you're talking about.
Yeah. How's that? How's that one? Big wheel? No. Nothing. No. Know your audience before you build a game around them.
Yeah, no kidding. You could have picked something from at least the 90s. I mean, Christ.
I didn't know it was going to go like this. I swear. All right.
The next game is going to be about Get Smart and Beverly Hillbillies. So
Right. Mike. Let's round it out. Gina, what did you say?
I don't know. I just thought of something funny that I would like to see him, and I came up with a gondola.
Oh,
that would be cool.
fantastic. That would be good.
That would be good.
Well,
all right, Mike, we're gonna do something a little different this time.
Okay.
Being that you and Jack tied, I'm gonna say what is it? Where is it? I'm gonna say I win. Lowest score. Actually, no. Jack and Mike win. They tied. They tied for first place with 1 million points. I came in last place, 500,000.
Jack, high five.
And Mike, next time, maybe some match wits about climate change. Like that hurricane came in so hard. How hard was it? Why, it blew the blank off of somebody. Something like that maybe.
Anything, right.
I don't know. I was a pretty good I was a big fan of the taco truck.
I like that. That was good.
It's hard not to like a taco truck. Let me tell you. I am a
Hulk in the
huge
taco
fan.
truck.
Yeah.
You and burrito. All right.
Come on, it had diarrhea in it. You told me a long time ago anything with diarrhea in it is the winner.
That tends to be it. All right.
Bad sushi truck.
Yeah.
That's a bad. Oh, that would have been good. All right. Gina, thanks for joining us. Mike, Jack, thanks for joining me. I'm going to run the closer now. You've just enjoyed another awesome episode of the Mythwits podcast. Catch us live on Twitch, Mondays, 9:30 p.m. Eastern Time. Jump into the chat room and ask our guest questions. And we had some this time. Twitch is working properly. I thought there was a problem, but nope, just a matter of people getting in there. If you missed our live show, you can always catch the encore episode at YouTube.com/Mythwits. Find us at Mythwits.com and on Facebook, Twitter, YouTube, Twitch, and SoundCloud as the Mythwits. Do the like, follow, subscribe thing wherever it's appropriate. Please give us a bunch of stars and a review on iTunes. Screenshot that shit, post it on our Facebook page, and I'll personally send you something special. Mythwits is part of the TSR Podcast Network. If you like us, you're bound to like some of the other shows on there. Check out tsrpn.com. Mythwits is a Creative Commons product. Make sure to check out Stu187.com for more cool stuff and join our mailing list. Please join our mailing list. I'd like to send some stuff out in the news and stuff, but I'm waiting to get enough people. Thanks for listening. Tell your friends to tune in. And until next week, Mike?
Oxygenation event and nuclear power.
That's awesome. All right, everybody. Good night.